Hello guys, in this video I'll be doing some proofs on hyperbolic functions. The questions are right here with me. It was a stimulation exam I gave lower C science students to prepare them for their upcoming sequence. I was not really having time to type out the questions so that you guys can see, but anyways, I'm just going to try my best. So the question that really interests me is this question. The question first of all says that you should maybe show that sinh inverse of x is equal to the ln of x plus the square root of 1 plus x squared. And then now we later show that for every theta in the interval 0 to pi, we have that sinh inverse of the cotangent of theta is equal to the ln of the cotangent of theta on 2. This question really caught my attention. All right, so let us solve the question. All right, it's a very nice question. Okay, so to prove that sinh inverse of x is equal to that, I'll start by I let y to be equal to what I am proving, sinh inverse of x. Then I take sinh on both sides, sinh y will be equal to x. But now what is sinh y? It is half times e to the y minus e to the minus y. So it means that if I all multiply by 2, I'm going to get 2x to be equal to e to the y minus e to the minus y is 1 over e to the y. Okay, now I'll multiply all through by e to the y, so I get 2x e to the y is equal to e to the y times e to the y is e to the y all squared, then minus 1. So I'm going to form a quadratic where I have e to the y all squared minus 2x all of that times e to the y, then minus 1 equal to 0. And I solve for e to the y. So this means that e to the y will be equal to 2x plus or minus the square root of 4x squared minus minus 4. I think when you do that, all divided by 2a, 2 into 1, which is going to give us 2 in the denominator. Here we have 2x plus or minus. Here will become plus. You factorize root 4, you have 2, the square root of 1 plus x squared. Okay, that's what we have. All right, so from there, let us see what we have. So we have that e to the y is equal to 2x plus or minus the square root of 1 plus x squared. No, we have 2. There was 2 there. Oh, sorry about that. So we had that 2x is equal, e to the y is equal to, we have 2x plus or minus 2 the square root of 1 plus x squared all divided by 2, which will give us 1 plus or minus the square root, no, x, it's like I'm drunk today, x plus or minus the square root of 1 plus x squared all divided by there's no division sign again now. Voila, this is what we have. But now what do we know about the square root function with the exponential function? We actually know that the exponential function e to the y is always positive. It therefore means that we are not going to take the minus sign, which means e to the y will just be equal to x plus the square root of 1 plus x squared. Because if you take the minus sign, it's going to x minus that square root will produce something negative. Okay, so from here we need to take ln on both sides. So ln e to the y will give us the ln of x plus the square root of 1 plus x squared, which means that y will give us the ln of x plus the square root of 1 plus x squared. But what is y? It was sinh inverse of x, to give us the ln of x plus the square root of 1 plus x squared. So that is it as required. We are done with that. Now the second part of the equation, we have to prove something else. So for the second part, we need to prove that sinh inverse of the cotangent of theta is equal to something, but this is actually equal to the ln of the cotangent of theta plus the square root of the cotangent squared of theta plus 1. I have just replaced my x basically with the cotangent of theta. Okay, if you check the previous formula, anywhere you see cotangent of theta is x that was there, so there's no big deal. All right, now from here, what do I do next? I just need to simplify the right hand side. Okay, I need to simplify the right hand side. So simplifying this right hand side, we basically have the ln of the cotangent of theta. This is square root of cosec squared theta. Yes, cosec squared theta. Okay, now remember that theta is actually in an interval 0 to pi. That's the interval of theta. So this will give us the ln of the cotangent of theta plus the square root of 1 over sine squared theta. Okay, this will give us a ln. Here's a ln of cot theta is cos theta over sine theta, then plus 1 over sine theta. I'm just taking 1 over sine theta because sine theta is positive in the interval 0 to pi, so no need for the absolute value again. So this is just going to give me the ln of, I add the numerator, cos theta plus 1 divided by sine theta. That's what we have. Okay, so sine inverse of cot theta, we have seen that it is the ln of cos theta plus 1 divided by sine theta. If we use the half angle identity, we are going to have the ln of cos theta plus 1. You are going to have 1 minus t squared over 1 plus t squared plus 1, all divided by 2t over 1 plus t squared, where t is tan theta on 2. I hope we know this. So this gives us a ln of 1 minus t squared plus 1 plus t squared, all divided by 1 plus t squared in the numerator. Then the denominator is 2t all divided by 1 plus t squared. This man cancels this man, and then at the end of the day we have the ln of the numerator will just have 2 divided by the denominator, we have 2t. So this gives us the ln of 1 over t, which is the ln of 1 over the tangent of theta on 2, which is the ln 1 over tan theta on 2 is cot theta on 2, and that is a proof. Thank you guys for watching, and see you in the next video. If I was too fast, tell me. Thank you guys. I was just doing this video for fun. I'm actually tired, so if you understand, fine. If you don't understand, still fine. But I was just tired and had nothing doing. Okay, so that's why I just said that to do nothing, let me better do a video. Some people are going to understand, some are not going to understand, but it's fine. I'll do more interesting videos later.